Charts and graphs can be very useful in many settings. They give us the quick scoop on information or data that we might have a vested interest in. In this outline, we will take a look at various types of ways to visualize categorical and numerical data. The first type we are going to look at are bar charts or bar graphs. A bar graph is used for categorical data to illustrate either the frequencies or the relative frequencies for the categories. Example 1 says a group of 383 college students were surveyed and asked what their major or intended major was. The results of the survey can be seen in the bar graph below. Part A says estimate the number of college students that intend to major in nursing. So notice that on the bottom of our bar chart, we can see all of the different majors that are listed, and we want to go through and we want to try to find nursing. So nursing is happening right here. And if the way that we read the bar chart is we bring it over here and look at this number. So as you can see, nursing is somewhere between 30 and 40 students. So the frequency is right here, and that's representing the number of students. And so that bar is definitely looking closer to 40 than 30. So it's going to be somewhere between 35 and 40. I would probably estimate that to be 38. So I would say about 38 students are intending to major in nursing. Part B says estimate the number of college students that intend to major in art or education. So notice that there's the word or there, so that means that we want to take the number of students that are intending to major in art and add them to the number of students that are intending to major in education. So for art, here's art, and I'm going to drag that across. So that definitely looks like it's 20. So this looks like it's 20, and then education. Education definitely, so education's right here, and that definitely looks like it's at 10. So if we add those values together, then we get 30. So about 30 students intend to major in art or education. And part C says, estimate the relative frequency of the college students that are not undecided. So notice that the undecided is the last bar here. And we want to basically, first of all, we want to count the number of students that are not undecided. And there's two ways of going about this. One way is you can add up all of these majors that are not undecided, and then that would give us the frequency, and then we can calculate the relative frequency by taking that number and dividing it by the total. Now, I do not want to have to go through the work of adding all of those up. There's an easier way to do this because we know that in total there were 383 college students surveyed. If we take 383 and subtract the number of undecided students, then whatever that number is, that's going to represent the number of students that are not undecided. So undecided is between 40 and 50. That wasn't really a straight line, but I'm going to estimate that to be 42. So we have 383 minus the 42 undecided students. So 383 minus 42 gives us 341. So 341 students are not undecided. And we want the relative frequency. So we want to take the 341 and divide that by 383 so that we can get the relative frequency. So I'm going to divide that by 383 and we get 0.8903. So this, you always want to box your final answer. So that 0.8903 represents our final answer for the relative frequency. The next type of visualization that we want to talk about are line graphs and line charts, which are synonymous. Line graphs or line charts display information as a series of data points connected by straight line segments. They are often used to visualize a trend in data over intervals of time. Example 2 says, below is a graph of the number of cumulative confirmed COVID-19 cases in King County, Washington, between April and October of 2020. This data was taken from the Washington State Department of Health. Part A says, in which month do you think COVID-19 cases grew the fastest and why? So notice that this is not a straight line, so it's not a linear function. However, it is made up of linear segments, and the place where it's going to grow the fastest is going to be determined by the slope of each of the line segments. And it looks like here to me, if you look at this portion or this specific line segment, that has the steepest slope. And so we would say that the month, or maybe we could say the number of COVID-19 cases grew the fastest between July and August because the line segment there has the steepest slope of any of the line segments. So that's how we know. Part B says approximately how many cases were there in May. So we want to go over to the bottom axis, and here is May. And if I drew a line over there, it's somewhere between 5 and 10,000 cases. And I'm going to approximate that to be 6,000. So about 6,000 cases in May. Part C says approximate the number of new cases between August and September. So we want to find August and September. So those are happening right here. And we need to approximate how many total cases were happening in August and in September. So here we need to approximate those values. And that looks like it's pretty close to 20,000. So I'll probably estimate that to be like 19,800 cases. And this one, I would say maybe 15,200. So those are my approximations. You might have approximated it slightly different, but that's what it is. It's an approximation. So because those are the cumulative totals, if we want to figure out how many new cases happened between those months, we would want to subtract. So we'd want to do 19,800 minus 15,200. So 19,800 minus 15,200 is about 4,600 cases. So about 4,600 new cases popped up between August and September.